Hey classes, welcome back. We're going to go through the class procedures today, some of the things that we did today to try and get us into the routines for the school year. We're only in week 2 here. And also some of the wow factor from the first couple of days. Over the first few days of class, we had some really big numbers that we threw out at you, partly because we want to give you a little taste of scientific notation, and partly to deal with some of the numbers, see some of the numbers with which we deal in science that are huge or really, really small when we're talking about values, say the size of a particular molecule or the size of the universe. This is the cool part about science. So let's jump right in. Let's keep it quick and to the point. And if you look at, we're in week 2 right here. We start off talking with the brain pop on measuring. Now, last week we already started to use a meter stick to measure the distance across the room, the distance, the height of the room, and gave us volume, length, width, and height. One of the examples for volume in terms of the cubic centimeter thing was when we took, let me reach over here and grab this little guy. This is 1 cubic centimeter. And one of the nice things to do with a metric system is a cubic centimeter is exactly the same thing in terms of volume as a milliliter. So when you look at a liquid measure, a milliliter, say you have a water bottle, it's got 900 milliliters in it. We saw one of those in class today. Those 900 milliliters are the same thing as 900 of these little cubic centimeters in terms of the volume, the amount of space it takes up. Talked a little bit today about the difference too between mass and weight. In other words, if you go to, say, the moon, a 3-day trip to the moon back in the old Apollo rockets in 1969, we first went to the moon, and the astronauts were able to leap higher there, even having a very massive spacesuit on, because the moon's gravity is only about 1/6 the Earth. So the actual size of the person didn't change. As a matter of fact, the person actually was more massive if you include the spaceship, or the spacesuit, excuse me. But in terms of being able to leap higher and move faster, that was one of the things that showed the difference between mass and weight. There's still the same amount of person there. It's just that the weight, the pull of gravity, in terms of newtons on the moon is far less, 1/6 that of Earth. That was also one of the really cool things that we saw in a book. We mentioned the book briefly, and we'll refer to it throughout the year. James Kakalios' book. He's a physicist. He does the physics of superheroes. As you get ready for high school and college after 8th grade and high school, I would really encourage you to check out that really fun book. He takes the idea of a superhero and says, okay, if the person could do this, if they did have this one extra special ability, what would be physically plausible from the comic books? He's a huge comic book fan. Really check that one out. I'll try and link to it down in the comments below, down below the video. Moving from there, we had our first formula, density, mass over volume. I have in the back of the room and around the room these very standard sized boxes that all contain the textbooks that I'll be passing out at the end of this week. And if you look at those boxes, they're all very heavy. I had to lug those in here. One of them was empty, and I didn't know that. And have you ever done that where you walk up to a box, you assume it's going to be really, really heavy, and then you go to pick it up and you go, whoa, and you accidentally, throw it across the room by accident because you fall backward. The point is, all those boxes are a standard size, but if you're talking about density, that's a good example of how you can have the exact same size, but one can weigh much more than another one. Same amount of space is being taken up, but yet one contains much more matter. And if you're looking at our key terms, these are our key terms. Most of the times at the beginning of the week, you're going to see usually about 10 key terms up here. Sometimes you'll even see some key terms that went to previous weeks. Key terms are very, very important. They're kind of like our anchor. When you're looking at learning any subject or learning a sport or learning the basics, say you're taking guitar lessons, you learn the notes first and then you kind of eventually learn to play the melody and the music. Key terms are a little bit like that. In education, they call that Bloom's taxonomy. You start with kind of the basic ideas, in this case, definitions. What do these words mean? We're going to be using these particular ones throughout the year. And from there, after you get the basics down, you can you go deeper. You go into a deeper level of understanding. Length, volume, mass, we've used those already, as a matter of fact. These are the ones we're going to really start hitting tomorrow. You notice the title up here, Life, the Universe, and Golf Balls. I try and name the lectures if I can. I'm going to reach over here and grab a golf ball because we're using golf balls today for a really basic experiment. That's listed on this side of the board. And I won't go ahead and pull that one over right now. I'll just get right to the point where You drop a golf ball and you're trying to get a relationship between the height from which you dropped it to the height to which it bounced. In other words, if I drop it from 100 centimeters, which we did, how high does it go? We do 3 trials on that. If I drop it from 75 centimeters above the ground, how high does that go, etc. We're going to be using this tomorrow to talk about the difference between variables in an experiment. Also, how you can figure out the relationship between what we call the independent and the dependent variable. This will cycle us back to that thing that we saw about the Hubble constant, the Hubble law, which helped Hubble figure out the size, the volume of our entire universe. Now, one of the big wow factors things that we tried to get to today was when we did our experiment last week, we were using volume to try and give students an appreciation for just the size of the universe and the age that we're talking about. The number that I gave as the number of galaxies that are in the observable universe is 200 billion. We're seeing about 125 billion right now based on the Hubble Deep Field View, but the James Webb Space Telescope will likely increase that number to about 200 billion. And if you're talking 200 billion galaxies with an average number of 200 billion stars per galaxy, you're talking 46 trillion stars in our universe. Again, to illustrate the number of stars we're talking about, we took little grains of salt, which again, we'll get into the chemical composition of salt later on this year. When you look at salt, we looked under a microscope, we could just about fit 20 along a centimeter. So 20 times 20 times 20 would tell you how many grains, 8,000, that we could fit in a cubic centimeter, which I just held up a second ago. If you do just a little bit of basic math, you would find that to fill this entire room with about 1/3 of a meter, about a foot deep with salt, if each of those grains of salt were to represent one single star in our galaxy, that would be just about the number of stars it would take to show the Milky Way. In other words, our whole classroom right here filled to about 1/3 of a meter with salt would show all the stars in our galaxy. But if you wanted to show all the stars in the universe, you'd have to fill this entire room, an entire standard size classroom here at IBL, all the way floor to ceiling with salt. And then you would need 11 million rooms that size to show all the stars in our universe. So a little bit of basic math, that's why we showed just a taste of scientific notation, basically exponents, which we're going to be using throughout the year. And we're going through the steps tomorrow to show how you take one variable, the independent variable, you take another variable, the dependent variable, and you show, hey, is there a relationship between those two? And most importantly, this is the big thing that we do with science, can I make a prediction with it? This I love. It's where observation, math, and experiment kind of meet in science so we can see if there's a relationship between two things. Hubble did that where he was able to take the relationship of the distance of a galaxy from Earth and relate that to the speed with which it is moving away from us. Last little thing, and this goes to like the mysteries of science, if you will, or the mysteries that we're trying to figure out using science. They just found out in the neighborhood of 25 years ago that our universe is not only expanding, but it's speeding up. And the golf ball, in the text of the golf ball, we use the example in class, it would be a little bit like taking this golf ball, throwing it up in the air. We're used to throwing things up in the air and being able to catch them again because they go up, stop, and they accelerate back down again. Here's the deal. It's a little bit like taking this golf ball, throwing it up in the air, and having it continue to accelerate until it actually left the Earth. That's what we're noticing with our universe based on the observation from the Hubble Space Telescope, the observations that we've seen, and it's rewritten astronomy. It's rewritten our what we think in terms of how the universe is expanding. So, I've thrown a lot at you the last couple days. The most important points are, hey, these are our key terms for the week. I'll put the notes out there online. The notes always kind of recap and recount what we've done the last couple of days, so there's a lot of overlap. And really, the students are responsible to make sure that they get each and every day the notes into their interactive student notebook. See you next time, and look for the notes online. We have our first open note quiz this week. They'll be online. Take care.